Hello everyone and welcome to this session, which is mainly related around the Australian Earth and Environmental Science infrastructure groups and how we're actually starting to coordinate through an organisation called AuScope, and I'll let Rebecca explain that. But now we're starting to look seriously at our international connections to see if we can't do some better sharing. So first of all, I would like to acknowledge and celebrate for this session the first Australians on whose traditional lands we meet and pay our respects to their elders past and present. So just quickly so you understand what our series of short talks are and the order that they're in, we're going to start with Rebecca telling the story of how the E&E groups have got together to start to share their experiences. And as I said, we've noticed in earth sciences, in oceans, and in the biodiversity groups that they've got these really good connections to international groups. And then we've got another variant with Christine Laney from NEON, who's more starting as an international group that's connecting back into Australia. And so then I will finish with just a short talk on just how do we connect everything together so that we act local but are part of a global cross-domain interoperability framework. So while these talks are going on, please put your thinking caps on and get lots of questions because we haven't prepared anything. Donald's going to be the moderator and we hope it'll be a really free-flowing discussion of ideas that people will want. And then Rebecca will pull it all together at the end. I'll also introduce David Lescinsky, and if he can come up now, because he's agreed to be, or stand up, he's agreed to be the moderator of all the short talks, and his name is Dracula, and you've got 6 minutes, and you'll be told 2 minutes before that it's time to get off the stage. Okay, so Rebecca, I think you're the first short talk.
Thank you, Lesley. So I'm Rebecca. I work at AuScope, which is Australia's geoscience and geospatial research infrastructure. Lesley's asked me to kind of give us an overview. So I'm not going to talk specifically about my organisation or international space, but how we operate nationally. Just a shout out as well, there is a booth. So come and chat with us. We're booth 7, kind of adjacent to the registration. It's called the Research Infrastructure Connected booth. We consider it the NCRIS booth, which is the National Collaborative Research Infrastructure Strategy, which is how the Australian government funds national research infrastructure. So we've printed out our poster as well. So it's in the booth, so you don't have to go far to the far-flung posters for the rest of the week. There's, just as a bit of history, there's lots of acronyms. I'll try to avoid saying them. It's probably about 7 or 8 years ago now. The National Earth and Environmental Science Facilities Forum started up. And so that was primarily the NCRIS, the research infrastructure organisations related to earth and environment. So we have Marine National Facility, the Integrated Marine Observing System, Terrestrial Ecosystem Research Network, etc. We can go through a list if you'd like after the fact, and we can put them in our notes. So that started off, but then it's also grown to include some government facilities. So we have representation from Geoscience Australia and the Bureau of Meteorology, as well as the Geospatial Information Council. So they are pretty important when we want to try to locate data in space. And then we have in Australia also some underpinning research infrastructures that really deal with compute and data and networking across the whole research ecosystem. So AARNet, I think we've got representation from AARNet here, Australian Access Federation, and then the Australian Research Data Commons, who we all know because they're organising this event, the National Computational Infrastructure, which is a large HPC and data facility in Canberra, And so we're all trying to operate together. I think I'm going okay for time. Excellent. So that is a group of people, they get together at a senior level, but we've also created Information Standards Advisory Panel, which is the data leads and adjacent staff members. We get together bi-monthly and talk about the hands-on operational issues we have with data, which has been really fruitful. So it provides this kind of cross-domain, but then also we're located across different universities, different government organisations in different cities. So we have this nice patchwork where we kind of cover most of the country and a lot of the different portfolios. 2 years ago, we had a conference called Integrated Earth, based in Canberra. We invited everyone clustered around the 5 spheres of the Earth. So we had the hydrosphere, the cryosphere, etc. And we gathered at the Academy of Sciences and we talked about what are the issues, I suppose, we see about doing integrated earth science going forward. So recognising the complexity of earth and environmental science and how, no sphere is in isolation. So while I suppose everyone understands we have complicated funding situations, we have quite rigid funding streams, the reality for researchers and scientists and educators is that we're working across all of those concurrently. 2 minutes, great. Okay, these are my take-home messages, so that's my introduction to our community. This is an anonymous quote that I heard this year sometime. So nothing brings people together like a funding round. So we had a funding round that just closed recently. It was supposed to close just after New Year's. And so we were all like, oh my goodness, we've got Christmas holidays and summer holidays and funding rounds. And so we were going to meet every week. And the funding round just kept getting pushed back for various reasons. Very legitimate reasons. We had a federal election in the middle of it. Lots of things. Anyways, it just closed, but we managed to spend kind of 9 months of the year meeting weekly. We had a drop-in session, and that provided us with a really great opportunity to kind of dig in a bit deeper about where we all sit. So we have different data complexities, different data volumes, different compute needs, etc. But we really do all overlap. We're using really similar stacks. We're using really similar compute and data resources. And so we're hoping to continue that momentum to work ahead. So I'll let you guys read that because I think I'm probably out of time. 30 seconds. Okay. No, I'll leave it there. That's fine. Otherwise, I just read that off. I'll pass over to Tim. Thank you.
Thanks, Beck. So, as Beck said, AuScope is one of those research infrastructures funded under the National Collaborative Research Infrastructure Strategy. We're the research infrastructure that represents the solid earth sciences and geospatial sciences as well. So this is kind of diagrammatically what we look like. So we support observational infrastructure deployed across Australia and on the seafloor. We support the operation of those tools like seismometers, GNSS networks, very long baseline interferometry telescopes, and a variety of other things. We also support membership of international communities like ANZIC's membership of the IODP and ICDP programs, the drilling programs. We support a whole bunch of data related activities, so repositories, data platforms, virtual core libraries. We have some hyperspectral scanning tools now and drones and a variety of other things. But we do have this data layer and then a value add layer, which is the simulation analysis and modelling program. So some of you might be familiar with G-plates, which is a plate scale tectonic reconstruction package, which adds value to the data we collect through all of our observational infrastructures. And we are also a collaborative organisation. So AuScope itself is quite small. We exist, we're a non-for-profit company established purely to operate this research infrastructure, but all of the infrastructures that we support are run through our nodes. So we have nodes at many of the Australian universities. We have nodes at Geoscience Australia and CSIRO. We work with some of the CRC programs, so the MINEX CRC program. We now, more than in the past, are also working with a number of museums to help store some of their data and deliver some of their data. And then we also partner with many of the other NCRIS organisations on collaborative projects like the Coast RI project, which is a collaborative coastal research infrastructure deployment involving many of the groups that Beck showed in her slide, looking at different aspects of how we monitor coastal change. So what Lesley really wanted me to talk about today is how AuScope connects outward and globally. So over the last sort of 4 years, we've been working very closely with EPOS, who we have a very close relationship with, but also a very close alignment in our structure with. And then more recently, also EarthScope and Earth Sciences New Zealand. And we've developed an MOU and a collaboration agreement with those 4 organisations to try to take some steps towards building a global research infrastructure for the solid earth sciences. And we're really very much at the early stages of that. I'll be giving a more detailed talk about that later today, and Helen Glaves is also going to be here next week for any of you who are hanging around for e-research, and she'll give a much more detailed discussion on that topic. But we're really excited by the opportunity that that connection is going to bring. And we also are really looking for other partners to join that collaboration, because we really are at the early stages of planning what the GRI might actually look like. But we also engage with a number of other international organisations. So I already mentioned the top line there. But in the geochronology and geochemistry space, we work with a number of international data repositories and data management organisations, including EarthChem, Astromat, GeoRock, and GFZ. And that's part of our EarthBank and AusGeochem projects that we've been running for a number of years now. I already mentioned that we support ANZIC, which is the Australian and New Zealand membership to the IODP Cubed program and the ICDP, the International Continental Drilling Program, and the International Ocean Discovery Program. We are involved in a number of geodesy projects, international collaborations like IGS and IVS, and we do that, I should point out, through our partner organisations. So it's Geoscience Australia that operates those instruments for us, the GNSS network and the Very Long Baseline Interferometry network, and they partner with the University of Tasmania and are members of these international organisations. And we also support IGO, the International Geothermal Association, and their International Geothermal Data Repository System. So finally, I just wanted to, this is going back to that sort of collaboration, I just wanted to point out that as we are looking for new partners and looking to grow that collaboration, that international connections with EPOS, EarthScope and others, we've got a survey available at the moment, so we would really love to get any feedback through that survey of what a GRI might look like in solid earth sciences, what stakeholders might find a value in that, and how you can help to be involved and help to shape that. And there's a QR code to that survey there. And that's me. Oh, it's not me. It's almost me. We'll say it's me. That was just our shared vision, but you get the idea.
Hi, I'm Catherine Tattersall. I'm here in this community as part of the Marine National Facility, which is a ship that is just sort of off the coast of Brisbane at the moment, collecting data from our oceans and delivering it to you through a real-time portal, and also being archived by a group of people who I have the honour of working with. But I'm wearing 2 hats today, and Tim started local and went global, and I'm going to start global and work my way back into the local. I have a couple of co-authors here, Pierluigi Butgaig, who works with the Intergovernmental Oceanographic Data Exchange and the Ocean Data Information System, and Mark Raybine, who I think is in the room with INOS. I sit on the management group for IODE, so that's the International Oceanographic Data Exchange. There are 3 main program components in IODE. There's ODIS, OBIS, and Ocean Teacher Global Academy. moving from right to left, that is capacity development. In the middle, we've got biodiversity data in the ocean, and on the left, we've got sort of an infrastructure, an interoperability infrastructure for ocean data, sitting under that UNESCO IOC umbrella. There was a move that we're all aware of to shift to open data in the global space. We all jumped on board in the ocean domain and started publishing our data openly and implementing, leveraging that open data in the way that we assess and do planning in the ocean. We started adopting care principles, and then the landscape that we operated in started to shift, and data started to become more competitive. People started to drop layers of governance over ocean data and open data in general. There was maybe less trust around some of the ways that open data was managed, and there was a fracturing and a splintering of the way that ocean data, at least, was being delivered into the global sphere. And so the IODE, who had been operating since 1961, people have been submitting data to our repositories since 1961 in a really stable way, found that the data that we had was splintered across a whole lot of different repositories and was no longer interoperable. IOD decided we needed to do something about that. We wanted to work out how to fix it, and part of that is getting our own house in order, both within the repositories that we store our data in, and then across IOD in general, and then to make the metadata that we use interoperable, and to connect with the community and build relationships with the community in the ocean data space. We developed a plan for a clearinghouse mechanism. So taking the components down the bottom there of the E&E ecosystem, feeding those through that metadata interoperability framework into a catalogue, and then to a portal that already exists but doesn't quite have the capacity that we want it to have yet, but we're on our way. I'm going to jump that slide. These have come from Pierluigi, who has an excellent mind but isn't in the room, so he can't stop me. This is the infrastructure design for ODIS, which is that Ocean Data Information System, which is the interoperability layer, the metadata exchange, and what we hope will become the information exchange across a federation of global ocean data repositories, many of them part of IOD, but also many of them not part of IOD. And the way that this is going to work, the core of the active metadata layer is going to be nothing new, nothing exciting, and that's exactly how we like it. It's JSON LD files from partners using accepted community standards, and leveraging the work of a lot of really great people who are at this conference in this way. So CODATA, CDIF and WorldFAIR are all part of that interoperability framework that ODIS is implementing. In Australia, we have a node of OBIS. So I'm putting back on my Marine National Facility hat now. This is at CSIRO, and we deliver biodiversity data using a commonly accepted standard to the international OBIS framework that then feeds into ODIS. And that's just one of many different ways that data does get into that ODIS platform. In the room, as I said, we've got Mark Rabine, who is here from IMOS. It's one of the NISA facilities, NCRES funded, and IMOS is also integrated with ODIS. So they've got that JSON LD layer and interoperability in their data catalogue. There is this global perspective to the way that we are managing our data in Australia. We always think about, whenever we're implementing any changes, how to make sure we continue to be interoperable with our international partners and the different groups that we publish into. So on the left, we've got what we do in the Marine National Facility and the partners that we work with. So right in the middle, we've got sort of our Australian domain partners shifting out to broader domains, shifting out to international partners, shifting out to World Data System and the UNESCO IOC, and then ODIS does the same, but rather than having that Australian focus, it's that global framework trying to connect with everyone who might hold data that is important for making decisions and driving policy in the marine space.
Okay, thanks, Catherine. So good afternoon. I'm the Engagement Manager for the Atlas of Living Australia, and some of the logos I'm now about to show you have already appeared in Catherine's slides. So I'm going to talk to, Lesley particularly wanted me to talk about GBIF, the Global Biodiversity Information Facility, but I'm going to go local back up to global again. We're going the other way again. I'm going to talk to you first about the Atlas of Living Australia. So my team, the engagement team, liaise and work with a number of different sectors, including my particular area of expertise, which is in the collection sector, so working closely with museums and herbaria, who are very active data providers into ALA and GBIF. We also have work touching on industry, particularly with environmental consultants, biosecurity, restricted access species data, and citizen science. So, moving along. So, for the Australians here, like I say, I'm going to start local and start talking about the Atlas of Living Australia. And as Catherine already said, ARDC is one of the data providers into the Atlas of Living Australia. The Atlas of Living Australia is an NCRIS facility hosted by CSIRO. ALA originally came from the collections community. The genesis of the idea was from the collections community, who the museums already had started to share data between them, and the herbarium community were actively sharing data between them, and they both had their own websites. So a number of years ago, when the NCRIS facilities were first proposed, it seemed logical that, given that plants and animals don't live separately in the world, they all live together, it made sense to have a single website that would be the place where you could find information about both plants and animals and all the biological things that are not plants and animals. So we also have the first director of the Atlas of Living Australia here in the room with us, Donald, who will be managing the discussion a little bit later. So now the Atlas of Living Australia aggregates approximately 150 million occurrence records. And an occurrence record in the biodiversity sense is defined as a biological organism, could be a plant, animal, a fungus, a microorganism, or any of those, that someone has either collected or observed at a place, on a date, and at a time, and with a person or people involved. That was the original definition. It is now starting to be broadened, though, because what we're now finding is that we've got a whole lot of machines coming along and making those observations for us. So that's introducing new complexity into the type of data that needs to be shared. There's about 1,200 data sets, some of which are refreshed on a regular basis, and some of which we've only ever ingested once. We strongly recommend that the data be openly licensed, and about 99% of it is licensed with a Creative Commons licence, which does allow us to interoperate much more freely. However, again, we've got there's a caveat on those statements, and the caveat involves restricted access species data, for example. So restrictions might be imposed because the taxon that you're looking at is restricted in a particular geographic area. It might be restricted because it's on a threatened species list, for example. We're also now just starting to talk with Aboriginal and Torres Strait Islander communities about cultural access and restricting data because there's a cultural reason too, and that species is culturally significant for some reason. Okay, so let's not talk about that now. What ALA is not. So ALA is an aggregator. It's not a canonical or primary source. So we aggregate the data from somewhere else. It harmonises species occurrence data from the many providers to allow the records to be mapped and visualised. What we are not is, although some of us do have field biology backgrounds, we're not doing the primary data collection. The data providers out there in the museums, the herbaria, government agencies, citizen scientists are the ones who are actually doing the data collection. So GBIF, moving on to GBIF. So GBIF is the global version. It's the grand aggregator, and ALA is the Australian node of GBIF. So GBIF scales up massively the number and mediates massively more records than the ALA does, up to, I think they're up to 2.6 billion records now. So it's got much more of a global outlook and perspective, and involves itself much more in the really big data and policy discussions, such as the Convention on Biological Diversity. It supports data mobilisation in least developed nations through programs such as the BID program, and is also engaging with the next types of data science in the biodiversity context. So what we've got on here, it's a bit small, but on the far side from me are the data providers, and on the near side to me are more of the users and the policy settings that GBIF works within. What we do often find within the biodiversity sphere is that the data providers and the data users are not necessarily the same people, and in fact they might never be the same people. So what the data the museums are collecting is not necessarily the same as what the users want. So my final thing is just a little word about standards. The data interchange standard that we use is called Darwin Core, and that's the basis. It can be used as the basis for data collection, such as citizen science observation records, but it's mostly a data interchange standard. It's currently in a revision phase, and there's a new version of Darwin Core called the Darwin Core Data Package, which will allow us to interoperate with new types of data, such as data coming from camera traps or drones, or all of the other machines that are now collecting our data for us. And that's me. Thank you.
All right, a lot of things are resonating with me on these talks, but I'm Christine Laney. I work for the U.S. National Ecological Observatory Network. And I'm going to talk a little bit about NEON and then how we're partnering globally. So the NEON is it is a National Science Foundation funded organization that's run by a nonprofit, and we have 81 field sites across the United States in all sorts of different biomes and across a great latitudinal and longitudinal gradient. We do remote sensing. We have instruments in the field, about 8,000 or so. And then we also do a lot of human collection of data. And so the data sets are very large. They're very well standardized, very well structured for interoperability within the network. And a lot of research can be done with them. These data are open and freely accessible to researchers all over the world. And so this is just a really quick schematic of just the overall data pipeline. So we just have data from our different systems, the people in the field, the people who are out on the planes, all of the instrumentation, and all of these data points are coming in 24/7, getting processed, getting packaged, and then being pushed out through our API, through our data portal, and also through other external repositories that are collecting or providing different domain-specific types of data. And so these include repositories such as GBIF, Ameriflux, Barcode of Life, etc. And of course, our data users are accessing any of these endpoints, the APIs or the portals or the repositories, and also contributing, especially to those external repositories where they can. And so in terms of data in general across ecosystems, we have a great span of information within our continent or within our country, and that spans to Hawaii and Alaska and Puerto Rico and others. But if we're really looking at ecosystem processes and drivers of ecosystem change across the globe, we really do want to get other field research sites that are at similar latitudes, for example, or similar biomes. And so what we really would like to see is a partnership with other similar research infrastructures across the globe. So we have partnered with several other systems, including TERN in Australia, and SEON, the South African Ecological Observation Network, and CERN, ICOS, etc. create that thing. And so there are a few things that we've learned with this partnership is that there's a lot of overlap in the types of data that we collect and the types of research interests that our end users have. So there are things as we come into this that we do know that there's these diverse data sets, that there's a lot of data available and that there's a lot of interest in these data. What we know a little bit less about is the data availability and how the data are licensed from one field site to the next, and how available those data will be for globally creating a global data set with those parameters. And then things that we either just have a hint of or maybe don't know at all might be things like how are these data managed outside of the contributing repository? Are they also in other repositories? What kinds of documentation are available for every single data set that's available throughout these systems? Are they consistent? Are they standardized? Are we able to actually harmonize the same kinds of data sets across our research infrastructures? And so we got a grant from the National Science Foundation specifically to do a pilot study across these different infrastructures. And it talks about data harmonization for ecological drought. And so these are parameters like air temperature and precipitation and soil moisture, soil temperature, soil texture, those kinds of things that you would think about as fairly simple parameters, but that there really aren't any global data sets, especially in the soils, for the soil temperature and soil moisture and so forth. But what we really need is starting to build those collaborative networks. And so things like providing ways for these international scientists to get together face-to-face and have discussions about data collection and data management, providing these pathways for people to participate no matter what kind of resources that they might have from their institution, training the next generation or the early career researchers, and finding out what they need to do things like global harmonization of data sets, and then actually doing the harmonization of the data, and then publishing under the FAIR data practices. So just very quickly, a little bit of progress and lessons learned. We've had a pretty successful run with this so far. We've been working with one organization at a time. First, we looked at NEON and TERN data sets, and then we've been adding the SEON data sets and adding the European LTER. And we've been developing some primary data streams and some pipelines, and working with early career researchers. And we're really finding, there are some lessons, oh no, time's up. Lessons learned that are, things about data sovereignty, things about some challenges that we're still struggling with in terms of data quality, data gaps, collaboration support, sustainability, those things. And so just my last conclusions is just, we really, there's a lot of desire to work with data globally, but the path forward for the early career researchers, for the next generation, and also in this world of where data access may be declining or may be more constricted, that's going to be some challenges that we need to work with in the future. So thank you.
Right, okay. Right, so it's pretty clear that this kind of emerged unexpectedly from these meetings we've been having discussing the NDRI proposals weekly since January, and I was the note taker and I started to pick up all these things about these international connections. So how can we get those back to help us in Australia? So you've been introduced to the motley crew that's known as ISAP, quite an eclectic mix, but we're talking to each other and we're working and we're meeting regularly. You've also probably heard a lot in this meeting about WorldFAIR, and it was a project that went from June 2022 to 2024, and it was started by CoData, And Simon Hodson, because on the National Committee, he contacted me to see if geochemistry would like to be part of it. And because he said it's an exciting project, all these countries, and for once the European Union's let their guard down and they're going to let Australia in, which they don't normally let us go for their funding. So we were able to get in and leverage it for everything we could. And the goal was to develop an interoperability framework for fair sharing across the disciplines. I don't know how well you could see, but it was everything. It was geochemistry, chemistry, social sciences, biodiversity, oceans, etc., etc. And we wanted to articulate the framework by which we discover and exchange data across those disciplines, knowing that there's going to be common elements for a certain part, and then you're going to go into your own bits and pieces. But what are those common elements? Now, as I said, Australia was heavily involved in the geochemistry one, and Steve McGecken at ANU was involved in the social sciences. And it's probably a bit sad to say that with Steve now going to the UK, we don't really have strong connections in the welfare community to what's going on in social sciences in the next generation of welfare. Okay, so the greatest achievement, and again we shared the slides, they're available, was pulling out these core discovery elements, the core access, controlled vocabularies, data description across those 11 groups into what we call the CDIF framework, and that is now available with a cookbook. So that's Welfare 1. And now we're into Welfare Plus. So we've got our achievements on the left and in the right. We're looking at universals. How do all these groups describe a sample? How do they describe an observation? We're working on provenance, we're working on mappings, and we're also working on the common elements of data description. So you can see what a powerful project this is, because that NESIF group now no longer have to try and do this interoperability amongst themselves, because we can look at what was done in this international project and start drawing it back. And the previous speakers have shown how well within the disciplines we're connecting with the groups, but you know, we need to get this back into Australia. And there are also these new WorldFAIR projects, and just to sort of say, like number 7 is Deep Time Digital Earth. We're involved in that in Australia. This number 3, X-rays, that's really interesting to the geochemists, but also to the oceanographers, because, not oceanographers, climate people, because that's doing a lot of work on HDF, SAR, common elements in that. Well, who cares if it's for synchrotron? You can bring that more general to other disciplines. So, where are we going with this lot? And so, as I said, while they're all nattering away, discussing things, we started to try and build this mapping of the landscape of where ISAP people were connecting with community-led organisations. So, for example, take ESIP. 7 of the groups are partners in ESIP. We've heard about how Turn is connecting into the infrastructures in Jerry, also in EPOS. And then we've got like the project-based stuff where we've got, like I would drill over the stuff and have been for a long time, this work that Pierre Luigi has been doing with Oceans and Jason LD. Come on, stop being selfish. We need that in earth sciences. And so it's actually understanding these core elements and bringing them back. And so I guess what I could say as a starting point for our discussions, can we coordinate a local E&E framework that can be operationalised within the broader global cross-domain interoperability framework? I think we can do it. And everyone says, I think you're ambitious, but to those of you who say that, I'll give you this quote. Never doubt a small group of thoughtful, committed citizens can change the world. Indeed, it's the only thing that ever has. So that's the ambition. And now I'll hand over to Donald, who, bless his socks. Have you got socks on? he's kindly agreed to moderate, and we want this to be absolutely free-ranging. Ask anything you like of anyone, and Donald's going to moderate it, and then we'll follow up with Rebecca. Oh yeah, we've got, how many online people have we got, Rebecca? I forgot about.
We've got two, we've got Meredith Gomes.
Yeah. Yeah. Okay, all right. I'll hand over to you guys.
Okay, thank you. Thanks very much. I'm Donald Hobern. I'm the Data Management Director for the Australian Plant Phenomics Network, one of those facilities on the earth science side that's funded by INCRIS. So we wanted to make this as interactive a session as possible. I suggest you ask questions, otherwise I'll just ask them and then it'll get very narrow. So do we have any questions from online, first of all? No, okay. Please do, online viewers, please send questions as well. Anybody in the room have anything they'd like to ask any or all of the speakers this morning? Thank you very much. And introduce yourself.
Hello everyone, Eric Laurie from the Australian Institute of Marine Science. I've seen a few groups now really using JSON LD as sort of like an interoperability layer between lots of systems. I was just wondering if collectively we could talk more about that. I mean, we don't currently export it, and was like, oh, should we? Like, where's it go? Where does it really shine in terms of connecting systems and working well with Google, or I don't know.
Well, first of all, any of the speakers want to say anything about JSON LD? Did you? No?
I think it's actually my frustration that in Australia we seem to be slipping back in a lot of areas to like more structural syntactic interoperability. We're not getting into semantics, and part of that is the vocabulary issue and also the JSON LD, but I'll pass over to the expert, or this one over here. Go for it.
Okay, I'll make a few. Oh, go on, Kate. Go, you go first.
I'll only have it for a second. So with OBIS at that international level, and Mark, maybe you're sitting very close to him, also may be able to speak, because I know that the Australian Ocean Data Network have implemented JSON LD. What we do is we will register the fact that we've implemented JSON LD with ODIS, and then they know to come looking. So the way that we're using it is sort of a two-step. Yeah. Donald.
Okay, thanks very much. So in the Australian Plant Phenomics Network, I'm all in now on JSON LD and RO Crate as a way of packaging it. So I would love to talk to anybody in Australia who is looking at using JSON LD, which is really just a JSON way of describing linked data, with the advantage that more people know how to process JSON than know how to process RDF. But for us, it's really about trying to join up our metadata description of all the context for any particular data set, all of the plants and the plots and the sensors with the actual sensor readings, and to be able to annotate everything in that way. And I think we can do a great deal without getting lost in the weeds of detail. And it's something where we can evolve over time. But more than anything else, I'd like to be doing it in our context in a way that identifies the sweet spots for joining up with others in the earth science space and others in the life science space, because what we're doing is sitting in the middle. We're doing experiments on plants, many of them in the environment, and I'd like my data to be exposed as much as possible. I think JSON LD, RO Crate, will help us do that. A forum for talking about it more in our context through ISAP, etc., would be good.
So a follow-up to that is, I guess, one of the things I've found with a lot of connected standards is they're really great in theory, but then when you look at the practice of what a lot of end users actually do, a lot of these systems are overly complicated, and people fall back to something that's super basic, like just reading some text, rather than using programs to analyze complex structures. So I guess what I was interested in, whether people have any good examples of end users really benefiting from putting in these more complex linked data type structures, sort of.
Remember the bit about we were all waiting for money. I'm waiting for money to do most of the things I want to do, so I can't actually give the good examples yet. But what I would say is that I've seen a lot of attempts over the years to replace relatively simple minimum information models like Darwin Core and others with very rich ontology-based models that just crash and burn because nobody wants to go through the pain of getting their data into them. And I think certainly for us, I'm seeing the JSON LD mostly as a way to focus a lot more on being explicit about what variables are in the data set and where those variables came from. So for me, it's about connecting up this value with this method and this sensor. And the specifics of what that variable means, I can point to an ontology to reference it. But really, I'm just more than anything else interested in being able to say, you see this number here? It came from us doing this thing. And doing that in a way that could be very common for anything for geosciences and others. But I think we can go beyond that, but keeping our ambitions real and pragmatic is good. And since I wasn't a speaker, I'm going to try and stop answering questions and let you ask some more. But I'd love to talk.
Hi, I'm Angus Nixon from University of Adelaide. I had a much less technical question. It's my impression that a lot of these sort of systems, when we're talking about interoperability and cooperation, is that they're working on quite a federated model. I think there was probably a few people in here in the database resilience talk yesterday. I kind of wonder if we should be maybe if there are opportunities to look at interoperability and things as more of a vehicle for things like data mirroring, particularly internationally, to sort of guard against various funding, political, cyber issues that we will have to deal with. And if that's something that people are sort of thinking about, or if there's a way that we can sort of use that to, I don't know, push progress a little bit harder as it's sort of an existential, potential existential threat, as well as, data access and better science, which, we would like to do.
Right. Unambiguously existential. Comments. There were. Yeah, it was very much related to some of the things you were talking about, Kat.
Wearing the marine domain hat. Are we talking about it? Definitely we're talking about it. Sometimes it feels like it's all that we talk about, which I hope is reassuring. In the biodiversity space, so I co-chair OBIS, which was one of the logos up on the screen, OBIS, not ODIS. So we have two acronyms that sound very much the same, are very different. OBIS is the biodiversity group. We have work underway right now to look at, of our national repositories, which ones are mirrored externally to their host organisation, which have ongoing funding, so that resilience, to ensure that the federated network of data suppliers won't just evaporate on us. The other thing that we do is that we do harvest all of the data. So we don't necessarily have all the underlying source data sets, but our transfer format is the same format that Ellie was talking about. So the Darwin Core archive at the moment will shift to the Darwin Core data package, which is that new format that's being developed. And those published derived data sets are harvested and then stored by OBIS, and we actually also publish them on the AWS Open Data platform in Parquet. So yes, we proliferate our data. We just make sure that we've got one point of truth, and we are always pointing there.
I think the power of what we're doing is I'm no longer trying to find a breakthrough group in earth sciences globally that's cracking this. And if you put your brain into neutral and say, what are we trying to achieve, then we just sort of see oceans. They've not only got examples, but they're scaling. And so, you know, what's the secret sauce in that oceans group? Can we leverage it for doing the same challenges in some earth science groups? So we're really broadening the people who are successful that we can leverage, if that kind of makes sense. And that's, to me, been the power of being part of things like WorldFAIR. And, I mean, WorldFAIR is not the only one. Some of us get a lot out of the ECIP Earth Systems Information Partners group, but it's, I think, getting out there and seeing who is being successful, which is kind of what you're saying. I want proof. Well, you may not get proof in your own domain, but we can see the proof in other earth and environmental science groups that gives you the hope to say, yes, we've got to change to the semantic, you know, move up to that semantic interoperability. We've only been trying for 30 years, but, you know, it's going to happen. It has to. We have to scale. And we're now in a bigger pool of people experimenting.
So, Angus, just going... Oh, sorry, I just wanted to have a follow-up there. Were there particular types of data that you're particularly thinking at risk?
No, not more sort of general...
Data,
yeah,
yes.
I come from the sciences.
Yeah. Yeah. Okay, thanks. Okay.
In the biodiversity sciences, certainly working with data providers around Australia, I think we, what we really notice, we handhold a lot because what we see is that there's very, very different levels of skill level, understanding, being able to even map to the shared data standard. So for some people who are, when I say people, I mean organisations, who are giving the data may or may not even be mapped to Darwin Core on a spreadsheet and kind of go, here, can you do something with this? So I think we have to also acknowledge that we are dealing with very different levels of data literacy, and for some of our data providers, to talk to them about JSON would mean them going, no idea what you're talking about. And so we've even instituted a biodiversity data mobilisation program just to get those little data give them some small funding to get the data even just into a format where it can be shared. So I think that puts the onus onto the bigger organisations or the organisations. So when we talk about federation, we're not federating from our data providers, we're harvesting as well, because we need there's so many data providers who just don't have the skills and capacity yet and may never to talk at that kind of about semantic interoperability, because the most that we can expect them to do is just get us some data, which is still valuable data and that we still really do want.
Another example of what you're talking about, Ella, is the Research Data Australia. Now, again, you go and talk schema.org to a lot of data suppliers, they glaze over, and all you want is the metadata of their, because RDA is an aggregator, we want to know where the data sets are. If we want them in schema.org, forget it. And when you get them into Research Data Australia, it then does do the bit to schema.org. And that's given people a kickstart to get up there. And I know that now, subsequently, some of the groups are deploying schema.org. So again, it's a very complex world we're moving into. So where can we develop these shared infrastructures that give people the leg ups in this new world of complexity?
Andrew Treloar, Australian Research Data Commons. So one of the closing comments on closing bullets on Leslie's slides was talking about the rate of technological change. And I've often thought that we have the challenge that the thing that will endure out of the work we do is the data, not the technologies that we're currently using to access the data. So I guess my question is, Donald, you're all hot to go on RO Crate now. That's great. 5 years ago, probably only Peter Sefton was talking about AuScope. How do we avoid, it's a question I guess for everybody, how do we avoid over-investing in ephemeral technologies in a way that diminishes the amount of effort that we can put into the data that needs to endure?
My immediate answer would, going back to what I said before about JSON-LD just being a way to serialize open data, and for me, open data just being a convenient way to increase the connectivity between the parts of my data, I would say that the more that we can follow recommendations such as CDIF, even if the specific technologies may not be everlasting, gives us the chance to automate the future migration of larger numbers of data sets more easily. I think also that we should always be asking ourselves, what could be different about our data landscape? One of the things that I like conceptually, although maybe this is just me at the moment, is that in this world in which we see more and more threats to major data repositories and sources of data, the idea of making sure that a packaged zip or tar or something for a data set contains everything in a sufficiently rich form that you would hope, at least with a little bit of effort, somebody could reinterpret and use those data, makes it possible to think about a world in which we do mirror more and more data sets in multiple places. We still have the master destination pointed to by the DOI, but you could imagine a future, if a benign DOI dictatorship, that would recognize that some repository had gone down and that there were 2 or 3 mirrors of it where the checksums still matched, and have mechanisms for pointing to alternatives. You don't like that idea. Go on.
So 2 comments. So I'm not an astronomer. I don't even cosplay an astronomer, but I know astronomers, and astronomers would probably at this point say, yes, we solved the first problem you described many, many years ago with a thing called FITS, which is a self-describing file format for astronomy data. It's so long ago that it's based on 80-column punch cards. Mm-hmm. So yes, I think the idea of self-describing files that are less brittle, shall we say, to technology change is a really good one. The comment about lots of different copies. The librarians at this point, again, I'm not a librarian, I kind of cosplay one occasionally. The librarians at this point would point you to a thing called LOCKS, which is lots of copies keep stuff safe, mm-hmm, yeah. Which is a system for distribution of journal files or individual journal papers, which I think got replaced by CLOCKS, which I can't remember what the C stands for. But anyway, there's existing models out there, and I agree, in a world where we can no longer rely on unnamed large countries to behave appropriately with respect to public funding of stuff, we probably need to think to a more distributed and more federated model.
Yeah. And of all the technologies in recent years that have begun with B, BitTorrent's still the one that I like best. There was a question at the back. Okay.
I know, good question online. Thanks. Hi, my name's Owen Forbes. I work at National Research Collections Australia at CSIRO. And my experience as a statistician is that interoperability and metadata standards tend to be quite opaque and impenetrable in terms of approaching it from the outside. Even as someone who lives and breathes data and works with data all the time, that without formal training as an information scientist and thinking in informatics terms, it can be a very difficult space to wrap your head around and understand. I'm conscious as well of one of the, I'm not sure of the source of the claims, but something that was claimed in one of the talks yesterday was that 80% of data sets never make it out of the lab and only 1% get cited and reused. And it seems like the development of interoperability standards often tends to happen by and is catered to large institutions managing large data sets. And there's a lot of emphasis placed on the universality and catering to every possible edge case of interoperability, with relatively little emphasis placed on accessibility and adoptability by non-expert users and by data scientists or applied data people who have little literacy in information science and informatics. So my question to the speakers and the panel generally is, What do you think differentiates the projects in metadata and interoperability that have done a good job at emphasizing accessibility and understandability and ease of adoption? And what are some lessons that can be generalized to try and make, people do a good enough job, do the 20% of effort that will get you 80% of the way there? How can we make those standards more accessible to a broader audience and a more distributed network of people doing data on a smaller scale?
Oh, come on, it can't be. Somebody must have real examples. Okay.
This is just a comment in general. Like, I think I found with a lot of metadata standards that I tended to rail against the fact that I found a lot of organisations spend an awful lot of time putting a lot of effort into all the technical fields, filling out hundreds of little fields that hardly anyone actually uses except in really edge cases, at the cost of actually making a human-centric metadata, which is a good description that someone could read and just understand. And obviously, having it in a human-centric text form is a lot less formal, but if you're taking the centric view that it's a human that's going to be reading this, can they understand it, can they reuse this data set, then to me that is, you don't want to trade off. You don't want a one paragraph abstract that's got all the technical fields filled in, but a human doesn't actually then can't use the data set. Because at any point, you can't really reliably have a computer analyze a metadata and go, oh, it's temperature data, therefore you can use it in this analysis. At some point, a human is always going to go through and decide, actually, this is appropriate for my purpose, which means you've got to communicate human to human as much as anything.
I think we're actually, from the data provider perspective, we're actually getting pressure the opposite direction, which is that we have end users who are saying, your data are not AI ready for me, and therefore I don't want to use it. I'm going to go to some other provider and use their data instead. And so we ask, what does AI ready mean for this? And what we discover is that it's often a very use case specific. So for images, we need the metadata and Croissant ML. We need we really don't want to just get data that are on Hugging Face, right? And we have our own data repository. So that's something like we are being asked by the end users to continue to follow these edge technologies that are developing very quickly, but our momentum is not, we're not capable of keeping up sometimes with those requests. So to me, it seems like what we really need is that structured metadata, but then we are looking at people using LLMs to actually query the information and make it human readable instead of trying to go the other direction, if that makes sense.
Thanks. I was trying to balance 4 ideas in my mind at once, but Christine, thank you. You've just taken one of them, which is fantastic. So the other 3, I think you were talking about making the metadata standards more accessible, or how do we get people to use metadata standards, or how do we develop metadata standards that are accessible? Yes, absolutely. They can be utterly impenetrable, and we can now point an LLM at them. And then we end up with your beautifully human-readable, lengthy, formatted, add a picture if you want, metadata. The other things that I know people do, and there are people in this room who do that, is build tools to help people write metadata. So you'll have a form, and there will be easily readable fields and say, tell us this about your data set, tell us this about your data set, and then that will be mapped to an interoperability to ISO 19115 or something. Not looking at the AOD folk, but I am. And then there are some standards, data formats that have embedded metadata in them that are relatively close to the formats that people in a domain use already. So when we talk about the Darwin Core Archives, it's basically a bunch, 3 CSV files that sit together that are sort of like structured tables that even if you don't feel comfortable with NetCDF or you don't feel comfortable with, you can open a CSV, you can have a look at it and it makes sense. And so there's a way of formatting data and embedding metadata so that it is friendly if that's what you're used to. And then there's always transforms and crosswalks.
Thanks. No, I think that's really good. The only other thing I was going to add, which may be a tangent, is that if we want to maximise the use of our data for use cases that are likely to be significant, I think we still need to spend more time on understanding what are the variables that could be extracted or inferred from our data or proxied that are likely to be useful in transdisciplinary cases. So things like, and I know they're not perfect, but the essential climate variables as setting an agenda of key properties, I think has worked well. On the other hand, the much more nebulous discussions around essential biodiversity variables, other than very good work on the ocean side in trying to make some sense of it, has generally not been operationalized because it was still very hard to turn it into anything that anybody could map to. And I think the thing is that we need a lot more opportunities to talk between disciplines so that we can understand the ways that we could be supporting each other with how we present and share our data. And it's not everything, because there's an infinite number of possible uses of all of our data, but trying to prepare ourselves for some of those connections, I think, could be enormously fruitful. We have a question from online. It's from Gabriela Pino-Chacon, at the Universidad Nacional in Costa Rica, who writes, what advice or priorities would you give universities in MLIC? Thank you very much. Middle and lower income countries, yes, okay. That are developing an ocean observatory as we have research knowledge, but very few resources and no government support. This case is for Central America. So specifically ocean observatories, any thoughts or comments?
So, as you know, in Australia, we're very lucky because our Australian integrated marine observing system is very well funded by NCRIS, and that's, one of the things that's been on the board here. I think without funding, the coordination is going to be key. Identifying what resources you have already in terms of equipment and people in your country, and building that community network of people. Also understanding what data management resources you have in place and what data you already have and where the gaps in your data are. If you're talking about biodiversity observing, as well as physical and chemical parameters, then I'd say lean into your OBIS node. I know that there's a very active regional Latin American OBIS consortium, and they would be able to provide regional specific advice. There are also opportunities for finding funding to collect data, or at least in the biodiversity space, when there isn't, when data's missing and it's needed for particular purposes. But I don't know of any, I haven't got any specific examples for the Latin American region. So
presumably, if somebody's in that situation of trying to establish a repository for a particular purpose, there's a stack of needs that have different costs and different availabilities. There's the storage, there's the preparation of metadata, there's the skills to put data in storage, there's curation, there's educating communities. There's parts of that that may be ones which are easier to handle at a transnational level, and others parts that do require more on ground, I would guess. Mark, did you want to?
Yeah, I'll add a few things. If starting up from scratch an ocean observatory, I'd look for some standard operating procedures that already exist. IMOS, the organisation I work for, have produced a whole range of these standard operating procedures. They detail what instruments we're using, what methods are in place, how the data are formatted and stored. So that can get you started. But then for how you may manage these data, I would perhaps look to what's existing out there, if you can access that, or if you need to do something, well, there's not something that suits you there, something low-tech that doesn't need a lot of technical resources and a lot of effort. Mm-hmm. So that might mean a file repository of some sort, and less focus on delivering through data portals or something like that. That's more unique and requires a lot more effort.
Yeah, thanks. It's at the back.
Sure. While I'm walking the microphone to the back, Mark, you reminded me Global Ocean Observing System as well is a United Nations funded organisation, and they would be able to offer advice in addition to the Australian IMOS standards.
Danny Kincaid, Biological and Chemical Oceanography Data Management Office in the US. We just hosted a workshop for Global Marine Time Series. It culminated in a workshop we had a research coordination network, culminated in a workshop in Bermuda just about this topic. There's a lot of output that got generated. GOOS is a great place to start. It's got recommendations and standards and that the sustained effort in how to coordinate the data management efforts across the global ocean observing systems, whether it's biodiversity or chemistry or whatever you're doing. They're hard. Time series are really hard. I think the joke is there are only 2 rules about time series data management. It's never to start a time series, and if you do ever start a time series, you never stop a time series. Like they're just really incredibly valuable. And to Lesley's comment, Pierluigi Buttigieg was helping this group get people who don't have a lot of knowledge about data interoperability and semantic know-how to really hit a low bar to get into ODIS. And there were project managers of Ocean Time Series that were able to achieve this. So there's there are resources out there, and if you even just Google them, you'll be able to hit a start.
Yep. Thanks. We probably have time for one very quick final question, if anybody has one. Oh.
Thank you. I'm Anka Hienol. I'm coming from Europe, and I represent European environmental research infrastructures. I know few of you, and few of you probably know about ENVRI. Lesley had our logo there. So in ENVRI, we are gathering the research infrastructures from all 4 domains, and we are trying to work together for example, metadata frameworks or interoperability frameworks, etc. ENVRI Hub is the gateway to data, resources, services, all in one place, so that the researchers don't have to navigate through silos. My question is more of a strategic one, maybe. Do you have such a thing in Australia? Do you consider to create an ENVRI Australia, for example? And would you contemplate in the future, which is not a near future for sure, joining up with the European one?
Thank you. Very timely question. The short answer is there's not. The answer to the second part of your question is I think we would definitely be keen to join up with the European ENVI hub. The thing that they've tried to do in Australia is start RIC, who Beck mentioned, so Research Infrastructure Connected, but it's much more that human interface. So it's really trying to connect the research infrastructures with specific users and try to help users who don't really know what infrastructure they're trying to engage with work out how to solve the technical problem that they have or the research problem that they have. It's still a pilot. They're still testing how that's going to work. It's I think yet to be seen whether it will work or not, but it's a different approach. And it's very much focused on translation, so it's really trying to understand what potential outputs you can enable by connecting those people. I think that there's still a need for us to have more of a interface like ENVI that allows people just to look for data or metadata or just discover data. Obviously ARDC also provides a lot of catalogues and stuff around data, so there is discoverability of a lot of the data, but it's not in the format that you're talking about. So I think we'd be very open to engaging and mapping out what that would look like. Yep.
I think also because I did that review of ENVI, I just felt that was a fantastic project, particularly where, like I always remember the project where across, it's both earth sciences, environmental sciences, polar, it was everything. And they had a specific project on bringing data in from sensors in remote areas, and then they found across all these infrastructures that there were about 4 or 5 trying to solve that problem, so they all got together. And I would argue that what we're doing in ISAP, we've only been really going fairly strong for about the last 2 years, and it's informal, and I think that we need a greater bridge between the earth scientists and the environmental scientists, which is like, so, getting your EPOS group together with the environmental groups. So, yeah, I think the ENVI model is something we could well aspire to.
Okay.
I'll give you the little person.
No,
oh, it's me.
So, thank you, everyone.
That's great. I feel wholly unqualified to do a wrap-up here. I feel like we covered off, we dove into quite a few details, but then also, finishing off with that strategy question is, I think, really reflective of where we are as a community. So, we plan in the Australian context, we're going to continue to work together, and we're a small population, and so we were all connected at some level previously, but now we're starting to work on those kind of timescales that we can actually, I suppose, collaborate on broader, more impactful projects. But I think it's also really like the technical questions that people were raising. These are the kinds of things that ISAP is able to deal with when we meet regularly. So that's something that I think this last 10 months or 9 months or however, have proven really interesting for us. Previously, we were talking more about the strategic level and just doing a deep dive for half an hour every 2 months. But the commitment of time needed to communicate these details for technology is really needed to be regular. We know this from things like IDW. You come for the whole week and you spend the whole week immersed in data issues, and then you can come away with something. But if you popped in, an hour once every 2 months, it'd be a different story. I think we still have a bit of time in terms of going forward. Like, I know that I would like to continue ISAP meeting regularly, and over the last 6 months even, we've had more people put their hands up from different areas within government departments, different research organisations that aren't necessarily directly funded by NCRIS, and so it's just continuing to grow, and we're just, Lesley and I and the kind of broader community, we plan to continue to, I suppose, foster that. But I'm happy to throw it open because we still have 10 minutes left. If anyone has any comments that they'd like to share or suggestions from their own experience about how to continue to progress this type of work, I more than welcome them. I'm kind of eyeing Lesley as well. Do you have anything you'd like to add, Lesley?
Just referring to this ISAP group that's formed, is initially we were the data representatives of the people working on the infrastructures. And what's happened in the last 12 months, I don't understand why, but I'm getting, oh, can we come? Or can we join? Or, look, do we have to just have one member per organisation? Look, I'd love someone to come and listen. And so I think we really are at this, where do we go? There was also, someone said, like, Anki, can we connect this with what you're doing? Well, we're what I call a smell of an oily rag organisation, in that we're just a group of volunteers. We're just getting together regularly, but where do we take this? And I did reference Earth Science Information Partners, and the 7 we have been having connections with that. There's actually a group called E2SIT, which is Earth and Environmental Sciences Down Under, which is Australia. Someone now wants to form one in Europe. There's talk of a European ESIP branch being formed. How do we bring this together? A, that we're effective, but we also respect the fact that, and I'm not asking for funding, but we don't have funding. And I don't know, I'm quite prepared to keep having more people come in, but it's just something based on what Anka's saying. Tim, you're forming this global group with the Solid Earth scientists. How do we connect those? Because we just don't want to reinvent the wheel. And right now I'm over to all you guys for ideas, because I just don't know how to do it.
Yeah, I suppose on that, Lesley, as well, I mean, it is an informal organisation, but we do sit underneath another committee, and we're all, I suppose, gainfully employed in our current organisation. So it's all relative stability, Donald. Okay, yeah, it's true. So while we're, it is informal, we're not we're all paid to participate, so that's helpful. Lesley, could you pass Andrew Treloar's after the mic there? ARDC Andrew Treloar.
Thank you, ARDC Andrew Treloar. So, a partial answer to next steps. Donald needs a lazy 500 million to implement everything that he's got in his big brain.
They've asked for less than ARDC has in the last funding round, obviously.
I have no idea what the total of our proposals were. However, I think we can all confidently assume that in this room we have all put in requests from the government for more money than the money that exists. I think that's kind of a given.
Oh, we've got the numbers. It was like, I don't know,
10 to 1? 5 to 1?
But that was just in NESIF what we asked for. It was like 7 times what was available.
Oh, okay, yeah, Guru and I were having a conversation about this last night. So my suggestion is, once we find out what we've actually got, as opposed to what we wanted to get, because it's going to be different, there is absolutely a role for the people in this room to get together and go, okay, how do we all achieve the best results that we can for the country and for our organisations by collaborating, given we now know what we've actually got funding for? So that, to me, looks like a really interesting next step. And given the department's flexible interpretation of the words soon and imminent that we've already seen, I'm not anticipating we're going to get any news this side of Christmas. So I would imagine that we'd be having these conversations early next year. But I absolutely see a role for bringing people together to try and work out how we maximise the outcomes from the funding. Sorry, I had a second comment. The ARDC International Strategy, which I'm sure you all know, has as two of its goals embedding international best practice and empowering international developments in areas that we care about. And coming back to Lesley's last set of slides about how do we do things internationally, I think we're already embedding international best practice in a lot of the things we do. I think we should also be thinking how we, once we find out what funding we've got, how we use some of that to empower the stuff that we care about, so that we're not just taking international best practice, we're contributing back to it. I know many of you are in organisations that do that now, but I'd just like to make a plea for empowering the organisations internationally that are doing stuff that we want to hook into.
Yeah, thanks, Andrew. I think that's one of the interesting things that we've been experiencing when we look at ISAP collectively, and I'll just talk while they figure it out, the amount of international collaborations that we're able to just kind of start to display when we get together is, we think it's pretty impressive for Australia, small nation, etc. So it's really, yeah.
That's the critical thing I want to emphasise, and again, picking up on Anchor, it's the international, and since COVID, Australians are not travelling as much to conferences. We share a time zone with Eastern Papua and Eastern Siberia, so if someone votes on the time for a meeting, Australians lose out. Australian membership in RDA is diminishing, and so I think we need to look more closely, because I will be arrogant and say we're getting very insular, and we desperately need to get better connections to some of the fab work that's going on in oceans, in biodiversity and that, so we can lift quickly and not go down rabbit holes, because we can see that others have tried, or this is working. Don't keep reinventing the wheel.
Thanks. And I think sort of in the spirit of that, for me, when I'm thinking about trying to make the data from the field I'm supporting useful for current users, available for long-term time series, or at least meta-analytical uses, and potentially also for transdisciplinary cases, and certainly for international users that may be in similar environments and have the opportunity to benefit from our wheat data or something like that. In all of these cases, my biggest problem is that I'm well aware of the many different areas that data management needs to intersect with, and there's a temptation either to spend your whole life learning about thousands of other initiatives and standards and best practice recommendations, or else just to invent your own. And finding the way through that is the thing that I think is really hard. And as I look across all of the different, there's extra dimensions as soon as we start thinking about trying to do this kind of thing at the environment and earth science scale. As I mentioned before, I kind of feel that I ought to be doing stuff with the people working in genomics and other omics areas, as well as the out-manifested traits of plants. So I've got life science stuff as well, and I can't have all those conversations. The thing that I have found most useful in the last couple of years for helping me find a way forward has been the cross-domain interoperability framework stuff from WorldFAIR. And the reason, above all else, is that it has helped me with my indecision paralysis. That I know I want to be able to describe my data well. I know that there is no perfect way to do it, but a reasonably credible activity, body, collaboration, project that comes out with some recommendations that say, all other things being equal, here's a good way to go, saves me so much time. And it then helps me to start working out what are the other things I need to do. And I think that what I kind of feel might be beneficial would be if we had a better way of bubbling up the standards, recommendations, and best practices that we're all aware of in our sub-communities, and finding ways collaboratively to expose those in ways that we can work together in little sub-units on them. And CDIF is doing that, and I don't want to reinvent RDA, I don't want to reinvent all the other things, but these bodies are giving us a lot of resources. We need to be able to find a better way to use them. And here in ISAP, of course, it's Lesley who comes along every 2 months and says, here are all the things she's aware of from all the conferences and committees and everything she's been in. That's really useful. But I think internationally, I don't know how it would work, but I think that's what I most miss. something that would help us to prioritise the things we look at to stop the time of having to look at 20 alternatives.
What a responsibility. So I think, Andrew Troy, you said before, I think it was you, how do we choose in standards are always changing, technology is always changing, data is the constant. And I think that anyone in the room will say, yes, data and good stewardship of data is the goal. And someone a very, 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 very long time ago said the only constant is change, and we just need to embrace that. They didn't say that last bit, that's me. So the way that we do this will always be changing. We choose the best tool that we can find, we go with that until there's change, and then we move to the next thing, and we just maintain the integrity of the data all the way through.
We'll wrap up there. Thanks, everyone. I think that was really great.